This lesson is on the substitution method, day 1, and we're going to be focusing on systems of equations involving just one solution. So just a quick review for systems of equations. We talked about types of solutions where there's no solution because the lines are parallel. There's one solution because those two lines intersect at one point. And there's infinite solutions because the two equations happen to be the exact same line. The equations are equivalent. So the one that we're going to focus on today are these one solution problems. So we're actually going to get values for x and y. Looking at this graph, this would be the solution. This would be the solution 2, 3. And in this solution, that means that x equals 2 and y equals 3. So in both of these equations, the x is equal to 2 and the y is equal to 3. So with the substitution method, what this means is that you are substituting in for a variable. So we've used this before. We've called it evaluating expressions. So for example, if I have the equation 3x and I want to know what is this expression equal to when x equals 9? Well, I would substitute in 9 in for x, so this would become 3 times 9, or 27. It works the same way if instead of x equaling a number, let's say that I still have 3x, and it's when x equals 9y. Well, x still equals something. Instead of it equaling a number, it equals an expression, 9y. So instead of x now, I could put this in as 3 times 9y. Now, since it's an equation, I wouldn't know the answer to this specifically because I don't know what y is yet, but I could multiply 3 times 9 and get 27y. So you can still substitute in for an expression even if one of the variables is unknown. So with an equation, following that same process, make sure for your substitution method that one of the equations is solved for a variable. So in this one, we have y solved so that y equals x plus 2. That means that in this equation here, this y also equals x plus 2. So instead of y, I can replace it or substitute it in with that x plus 2. So that would make this equation actually 2x plus x plus 2 equal to 17. Notice instead of y, I have x plus 2. I substituted in x plus 2 because now I only have one variable. Now I can solve this equation because there's just one variable that's not known. So first combine like terms, 2x plus x, to get 3x, and I still have this plus 2 equal to 17. Now using inverse operations, I'm trying to get 3x alone, so I need to do the opposite of adding 2, which is to subtract 2 on both sides. And I get 3x equals 15. Last step, the opposite of multiplying by 5, or by 3, is to divide by 3. And we get x to equal 5. So that means in both of these equations, x is 5. I know that x equals 5 because I solved it to find that. So now to find what the y-coordinate is, take one of your original equations. It doesn't matter which one. I always just choose which one's easier. And if I know that x equals 5, I can now substitute that 5 in for x into this equation. So 5 plus 2 means that y equals 7. And remember, for a system of equations, our solution is an ordered pair. Our x-coordinate is 5. Our y-coordinate was 7. So it's one ordered pair solution. So it's always good practice to make sure that you check your solution too. You can always graph it. You can see that the equations of these two lines, when graphed, cross at the ordered pair 5, 7. So now with this example, I have x equals y minus 1, and I have the equation 3x equals 2y minus 6. So my bottom equation is already solved for a variable. So what this means is that I can substitute in what x equals, this y minus 1, in for x in my other equation. So if I write my equation over here, 3x equals 2y minus 6, and I know that x equals y minus 1, I can replace this x with y minus 1, and the rest of the equation is still the same. So this time I'm going to keep my parentheses on the expression that I substituted in because I need to use the distributive property. I need to multiply 3 times the first term and 3 times that second term. So 3 times y is 3y. 3 times a minus 1 is a minus 3. And then I still have 2y minus 6. So I have variables on both sides and constant or number terms on both sides. I want to get all of my variables to the same side. So I could subtract off this side, minus 3y on both sides, but I'm going to end up with a negative y here if I do it that way. So instead, I would subtract off 2y on both sides, only because now it's going to keep this positive, because 3y minus 2y is a positive y. And then I have minus 3 equals, and these two canceled out, so equals a negative 6. Last step, to get y by itself, if I add 3 on both sides, now I have y equals a negative 3. So this means in both of my equations, this y here and this y here both equal a negative 3. The last step now is to substitute the value of the variable found in step 2, so substitute in negative 3 into one of the equations. I always look to see which one would be easier. So this one, the coefficient of y is just 1. It's easier to plug it in here. So if I take this equation, x equals a negative 3 minus 1, and that negative 3 came from here, y equals negative 3. This is the same as x equals a negative 3 plus a negative 1, or x equals negative 4. And remember, this is the ordered pair now, negative 4, negative 3. Because these two equations intersect at the same point. The solution to both is when x is negative 4 and y is negative 3. And again, it is good practice to check your work just to make sure you have the correct solution. So remember, this is x and y. If x is negative 4, this is 3 times negative 4. And if 2 is negative 3, this is 2 times a negative 3. And then we subtract 6. 3 times negative 4 is negative 12. 2 times negative 3 is negative 6 minus 6. Add the opposite, so negative 6 plus a negative 6, and we do in fact get negative 12 equals negative 12. Make sure you do the same for the other equation. X is negative 4. So if I plug in negative 3 for y, this becomes negative 3 plus a negative 1, and we do in fact get negative 4 again for both. So I know that I have the correct solution. One more example, this one, notice the variables are different. They're not x and y. You're still going to solve it the exact same way, just think of alphabetically what comes first. So when it's x and y, x comes first, it comes before y. Same thing with these. So A, B, C, D, E, this is like D, E. So the ordered pair D, E. D comes before E, so D is like x. So just to keep that in mind when setting up your ordered pair. Now this one, I don't have one of the equations solved for a variable. The second one is E minus D. So I could easily solve this for E by simply adding D on both sides, making that bottom equation E equals 11 plus D. So now if E equals 11 plus D in this equation, that means E in this equation equals the same thing. So if I take my equation and I substitute in that value for E, I would have 2D plus 7 times 11 plus D equals to 5. Now you notice the only thing that changed is instead of E, now I have 11 plus D. I substituted this equation in for the variable I knew in the other one. So if we solve this, again, use your distributive property, multiplying through the 7 times both. I get 2D plus 77 plus 7 times d is 7d equals 5. If I combine like terms, I have a 2d and a plus 2d, so that's 9d plus 77 equals 5. And then if I subtract 77 on both sides, I would end up with 9d equals a negative 72. And if I divide both sides by 9, I get d to equal a negative 8. So d in my ordered pair is equal to a negative 8. Last step, plug it into one of your equations. So we already solved e for e. So if I plug in negative 8 for d, e equals 11 plus a negative 8. We get e equals, these 8 negatives cancel off with 8 of these positives, and I have 3 positives left over. So this would really be the ordered pair, negative 8, 3. And again, it is good practice to check your solution. So remember, this was d and this was e. If I plug it into my first equation, 2 times the negative 8 plus 7 times 3. Negative 8 times 2 is negative 16. 7 times 3 is 21. These 16 negatives cancel off with 16 of the positives, making this equal to a positive 5. And that one checked out. Making sure to check the other equation as well. Substituting in 3 for e, a negative 8 for d. So minus a negative 8, this becomes 3 plus 8. And 3 plus 8 is 11. So this one also checked out. So what to do next? In your math book, before taking the quiz, go to page 258 and complete numbers 1 through 4 and 6, making sure to check your answers. There's a solution guide in the course. If you click on content and then course materials, there's a solution guide in the middle that has all of the even answers as well. Make sure you do the practice questions. There's not a quiz tied to this lesson, but there is a quiz for the day too. So make sure you understand how to get to your the correct answers for these problem numbers in the book. If you need more help, there's more resources in the online lesson. You can go back through those. And then you can also reach out to me if you need more help that way.